So far, you've only seen the begin method of a storyboard in action. You've either called the begin method explicitly or used the begin storyboard element within a trigger. But the storyboard class provides several other methods, including pause, resume, stop, and seek. Let's look at an example that demonstrates using some of these methods to programmatically control the playback of a storyboard. Our example has two images, a cat and a playful dog with the ball, that sit right on top of each other. What I'd like to do is, in my animation, animate the opacity property of the dog image, changing it from 1 to 0, basically making it transparent, and then because auto reverse is set to true, make it be opaque again. But during that animation, I might want to control my storyboard, named Demo Storyboard. I have buttons on my window which allow me to start, pause, resume, and stop the animation. If we look at the code, you'll see in each of those buttons we have code that retrieves a reference to the storyboard and then calls the appropriate method: begin, pause, resume, or stop. You've seen this exact code already, but you haven't seen calling the pause, resume, or stop methods. If we run this, if I start the animation, you'll see it changes from dog to cat and back to dog again over a course of 10 seconds. I can start the animation and pause the animation. At this point, we're sort of halfway through making the dog be completely transparent. I can resume the animation. And of course, at any point I can stop it, which sends us right back to the beginning or the end of the animation. In any case, you've seen that we can call the begin, pause, resume, and stop methods of a storyboard object. There are other methods of the storyboard object as well you might want to investigate. Look in the documentation and you'll see how to call other methods that allow you to interact with a storyboard object programmatically. All the animations you've seen so far have been straightforward. The properties change linearly from one value to another in a smooth transition. What if you want a more realistic, lifelike bounce or elastic style transition? What if you want a property to change as if it were on a spring? You could use keyframe or from, to, and by animations to approximate this, but it would take a lot of time to create a realistic solution. You saw an example earlier where I used keyframes, but I was just guessing sometimes on those spline curves. There's got to be an easier way to accomplish the goal of creating a realistic change to properties that you want to animate. The easier solution is to use an easing function. You can create your own by inheriting from easing function base, but most of the time you can use a built-in easing function. Well, let's look at a few examples. Bounce ease, for example, is a built-in easing function. Now, there are a couple ways you can use these easing functions. One of them is to have the easing mode set to ease in. Another is to have the easing mode set to ease out. Or you can have both ease in and out. Now, if you look at this little chart here, the horizontal axis represents time from left to right. So as you move from left to right across each of these three charts, you'll see a change in a value. The vertical axis represents the value of the animated property. The bottom represents the from value, and the top represents the to value. Assuming the ease in version for easing mode, imagine you're changing the height of something. Well, if the vertical axis represents the height, you can see it gets a little bigger, then goes back to where it started. Gets a little more bigger, goes back to where it started. Gets a little more bigger, goes back to where it started. And finally, on the fourth bounce, goes up to the final value. So say we're taking a button, starting with its height of 100, changing it to 200. If we were using the easing mode for bounce ease, it would go 100, 110, back to 100. 100, 120, back to 100. 100 to 150, back to 100. And finally, it would go from 100 to 200 over time. And you can see the bounces get farther apart. So it might go bounce, 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 and finally hit the value. Anyway, I'm sure my hand motions, which I'm doing here, are not translating well to this video. So soon we'll look at an example of how this works. Just take for a moment and look at ease out. In this case, we're starting at 200 and going back to 100. You can see that the bounces in this case go upside down. We go all the way from 200 to 100, then bounce back to 150, back to 100, bounce to 120, back to 100, bounce to 110, and end at 100. And you can do bounces on either end of this. You can bounce a little, bounce a lot, bounce more, hit the final value, and bounce back a little more, and finally end. There are other easing functions you can use as well. Back ease, for example, retracts motion slightly before it begins to animate. You can set the amplitude property to control the amount of the back ease. There's bounce ease, which you just saw, creates a bouncing effect. The bounces property controls the number of bounces, and the bounciness property controls how quickly bounces increase or diminish. The default is 2. There's a circle easing function, which accelerates or decelerates using a circular shaped function. We also have quadratic ease, cubic ease, quartic ease, quintic ease, who makes up these names, and power ease. Each of these creates an animation that accelerates and or decelerates using the formula f of t equals t to the x, where x is 2, 3, 4, or 5. That is, you can have a squared curve, a cubed curve, a fourth power curve, or even a fifth power curve. You have to go back to your math here. Remember, a quadratic curve goes up slowly, a third power curve goes up faster. By the time you get to t to the fifth power, things go from slow to fast very quickly. You can accelerate or decelerate your change, and for example, a quadratic accelerates or decelerates with the square of the time. The exponential ease uses an exponential function to shape the acceleration or deceleration. There's a couple more. There's elastic ease, which resembles a spring, oscillating back and forth until it finally comes to rest. The oscillations property controls the number of oscillations, and the springiness property controls how quickly the oscillations increase or decrease, and the default is 3. You'd have to play with that some. There's a sine ease function, which uses a sine curve to shape the acceleration or deceleration. Each one of these easing functions can specify an easing mode property. You can ease in, ease out, or ease both in and out. And that controls where the easing is applied. At the beginning, that's ease in. At the end, that's ease out. Or both the beginning and the end of the animation, that's ease in and out. Well, let's look at an example that changes a visible property of a control using an easing function to see how it affects the behavior. In this example, I have two rectangles. I'll start with the simple one first. This rectangle starts out at a height of 30, a width of 200, and then I have a trigger on usercontrol.loaded, which begins a storyboard, which has a double animation which changes the height of the rectangle over the course of 3 seconds from 30 to 200. So it will linearly change the height of the rectangle from 30 to 200 over the course of 3 seconds. I have a second rectangle up here, same size at start. We have a trigger that occurs when the user control loads. Again, we're animating the height, but this time, as part of the animation, we set the easing function property. We set the easing function to be a bounce ease. It has 4 bounces. The bounciness is 2, and we ease in, which means the bounce occurs as the animation starts. Let's run and see what this looks like. Here we go. Watch the rectangle on the right first. It's hard to watch both. If you watch the rectangle on the right, you see it linearly increases its height from 30 to 200. Now, in the same time frame, Watch the one on the left. It bounces a little, then it bounces a lot, then it bounces more, and it finally gets to the right height. Here we go. Bounce, bounce, bounce. There we go. And so by adding that easing function, we've told the height property not to change linearly, but instead to do it in 4 bounces. 2, 3, 4. There's the 4th bounce. So you can see what fun you'll have playing with easing functions to see how it affects the animation as you go from 30 to 200 using 4 bounces. In ease in easing mode says to do the bounces starting small and get bigger. If we change that to ease out, they'd start big and get smaller. In any case, you'll need to play with these easing functions to see what effect they have on your animations. Our next example uses a quartic easing function. A quartic ease starts very slow. Watch the slope of that line from left to right in the first chart. After it starts really slow, it starts speeding up quicker and quicker and quicker. So imagine you were changing a color from, say, yellow to red. In this case, we start moving very slowly, but over time, the color changes faster and faster and faster until it finally gets to its to value. The from value is yellow, the to value is red, and so it starts moving away from yellow very slowly until after a few seconds, or however long the time is, it starts moving faster and faster. If we look at the ease out version, we start moving very fast and slow down slower and slower and slower until we finally get to the value. If we use an ease in and out, as in the ease in out option, we start slow, we pick up speed, and then we slow down again toward the end. We're going to use a color animation where the from and to values represent colors. The bottom represents the from color, the top represents the to color. The steepness of the line represents the speed of the color changing. Ease in out, as I mentioned, starts slow, then moves fast, then slows down again at the end. It's as if you have hydraulic brakes at both ends of your roller coaster ride or something like that. Starts out slow, speeds up, and then slows down again at the end. Let's try an example which shows off this sort of color animation. In this example, we'll change the color of a rectangle from blue to red, both using an easing function and not using an easing function. I'm going to display this demonstration. Start by watching the right-hand rectangle. This changes from blue to red in a linear fashion over time. Let's watch it again. Watch the right-hand rectangle. Over time, it goes from blue to red very gracefully. Now, I want you to watch the left-hand rectangle. This one starts out blue, starts very slowly, ramps up quickly, and then gets to red first, but then kind of gets to orangish red and slows down into the final bits of red. Let's watch it again. Starts slowly, it gets to red first, but it doesn't actually hit red until the very end. It's a subtle transition. Watch it carefully. We're using a quartic ease on ease in out. It starts slow, ramps up quickly, and slows down again toward the end. What we're looking at is the relative rate of change of the color. Well, how does this work? If we look at the right-hand rectangle, we have a color animation taking us from blue to red in 3 seconds, and we're modifying the color property of the solid color brush, which provides the fill property for the rectangle. The left-hand rectangle has the exact same animation, except we've added a value for the easing function property of the color animation. We've used a quartic ease instance with the easing mode set to ease in out. And with the easing mode set to ease in out, it starts slow, ramps up, and then slows down again towards the end. You'll have to watch carefully to see what it's doing, but you can easily add any sort of easing function to your animation by simply adding an element that defines that easing function. If you want to learn more about the easing functions that Microsoft provides, you'll want to this website, which provides a sample of each of the easing functions. Although it's a Silverlight application, it's not specific to Silverlight and works anywhere you might want to use easing functions. Let's take a look at how it works so you can learn how to use it yourself. I've browsed to the sample page, and here you can see a drop-down list that contains all the different easing functions that you might want to work with. Let's try Bounce Ease, one you've seen already. The demonstration animates the canvas.top property of this rectangle here, much like we saw in our own examples. We can set the number of bounces, we can set the bounciness, and whether we want ease in, ease out, or both. Let's try ease in. In that case, the bounces start small and get bigger as we go through our 3 bounces. Let's try it. Small bounce, big bounce gets us to the final place. Let's try with ease in out. Let's see how to interpret that. We should start with small bounces, move through to a littler bounce, and a final bounce. Let's try that. Little bounce, big bounce, then big bounce, little bounce, little bounce. So you saw that behavior when I chose ease in, out. Let's try a different one. Maybe quartic ease that we looked at in another example with colors. Here, with ease in, we're animating the top property again. It should start moving very slowly and pick up speed over time. Let's try it. Starts very slowly, picks up speed over time till it gets to the final endpoint. Let's try ease in, out. This should start slowly, then move fast, then slow down again until it gets to the end position. Slow, fast, slows down again. So it's a matter of interpreting these charts. Remember, from left to right is time, at the bottom is the from value, at the top is the to value, and over time you can see that the steeper the curve is, the faster you're moving from the from value to the to value. As a quiz, think for a moment what this chart tells you. If we ease out, what is this going to look like? Time's up. Over time, we start moving very quickly and slow down until we reach the to value. Let's try that one. We start fast and slow down at the end. So you'll need to practice getting used to reading these charts. If I were you, I'd play through each one of these to see the behavior of the easing function so you can see how you can apply these to your own animations. You've seen how to animate colors, points, and double values, but what if you want to animate something like a brush? Should be simple. You just need to find the appropriate property and create the correct type of animation. What if you wanted to animate the gradient origin property of a radial gradient brush? Well, it's a point, so you need to add a point animation, and you must provide a name for the radial gradient brush so you can refer to it from your animation. We've never named a brush before, but you can. In our example, we'll do that. In this example, I have an ellipse named Demo Ellipse of width and height 300. Within that ellipse, we have a fill property set to a radial gradient brush. Now I've named the radial gradient brush Demo Brush and set its gradient origin to be 0.7, 0.3, sort of in the upper right corner of the ellipse. I have a gradient stop of white at 0 and blue at 1, so I go from white to blue in the radial gradient. I've also set up a trigger in the usercontrol.loaded, which will animate Demo Brush, animating the property gradient origin. You see, I set a name here so I could refer to it from the animation. Here the animation takes the gradient origin from 0.7, 0.3 to 0.3, 0.7. That is in the lower left-hand corner. We set auto reverse to true, repeat behavior forever, and we end up with something that looks like this. That is, the origin of that gradient animates from one edge to the other of this ellipse. Gives it kind of a 3D look or something. In any case, we didn't do anything special here. We just animated a property that we had never animated before, which was the gradient origin property of a gradient. What if you want to animate a transform? Well, it's simple to do that. I will warn you that you must create the transform even if it's empty. You have to have the transform created in order to animate properties of it. From that animation, you can set properties of the transform, and that's exactly what we're going to do. We're going to use a scale transform and animate the amount we're scaling. Let's give it a try. In this example, I have a button named Demo Button, which has a render transform property set to a scale transform. Notice there's nothing in the scale transform. It doesn't actually do anything. But we have to create it so we can animate it later on. I've set its name property to be Demo Transform. You've never seen me set the name for a transform before, but you can, and we need to if we want to be able to animate it. Notice also I've set the Render Transform Origin property to be 0.5, 0.5, which means any animation we use to scale the button will center on the center of the button. Well, we have up here a storyboard named Demo Storyboard, and we're going to react to the click event of the button by calling the begin method of this storyboard, and you've seen code to do that already. The target name for the first animation is Demo Transform, that's this transform. We'll set the target property to be Scale X, so we're modifying the Scale X property, and we're taking it from 1 to 1.2 over half a second, and we auto reverse. We have a second double animation, which modifies Demo Transfer's Scale Y property. We're scaling from 1 to 1.2 over a period of 5 seconds, and auto reverse is true. So when I click the button and run this storyboard's begin method, we should increase the button size to 1.2, or scale the button to 1.2 in the X and the Y direction, and then auto reverse back to the original size. Let's try it. Click the button. It scales up and back. Scales up and back. So you can see that we've added an animation to the scale transform for this button. And we've done that in reaction to the click event of the button. You can animate any property of any transform that you want to work with, and you can do it in a manner similar to this. If you're creating animations in code, or you're creating simple animations like we have, Visual Studio is fine. But if you're creating animations in design mode, or if you have complex animations, you might want to think about using Expression Blend. Let's try a demonstration which creates an animation in Blend that shows a ball bouncing and a rectangle sliding in the same animation. We'll do it first using keyframes, and then we'll add an easing function. In Expression Blend, I've created a project and have added a bouncing ball, or the red ellipse, and a bar, or the black rectangle. I need to add a storyboard because that's how you create the animation, and right now there's no storyboard open. So I'll click the plus sign to create a new storyboard, and I'll call it Bouncing Ball. At this point we get a new timeline, but it's very difficult to work with that timeline because it's so narrow. To get around that, I'm going to switch to a different workspace. I'll switch to the animation workspace, which gives me a little more room for that timeline. Now, if you have other windows open, you might want to close them, so you end up with just the Objects and Timeline window and the timeline appearing to its right. Now, it might be useful to look at the XAML that's been created for you, so I'll go up and look at XAML view, and you can see that we already have a resource, which is that storyboard named Bouncing Ball, and we have a trigger which will begin the storyboard based on the loaded event of a framework element. We haven't really set up the storyboard yet with an animation, but for now it does have everything it needs to get started. So here is our bouncing ball, and we're ready to set up our animation. Now notice that the artboard is surrounded by a red line, and it says Bouncing Ball Timeline Recording is on. By recording, what they're doing is allowing me to change any property, and they'll record that property change as part of the animation. Now, if that red border isn't on right now, you can select bouncing ball in the timelines here and make sure and click the little red light to turn it on. You click it now, I'll turn it off, or I can click it again to turn it on. And I do want it on for now. I want to drag the playhead to 2 seconds because I want to indicate where I want this ball to be at 2 seconds. There we are. I drag the playhead to 2 seconds, and now I'll press the selection tool, V, so I can select something. And with that playhead at 2 seconds, I'm going to drag the ball down till it just touches the bar. Straight down it goes. There we are. And so you can see we have the ball set at 2 seconds recorded as part of this timeline. You'll see a little red circle appears in the ellipse element here, indicating that we've used it as part of this animation. Now at the top of the timeline window, we have playback controls. We can click play, and we'll play our animation so far. You can see what we've recorded at this point in Expression Blend. Now if we examine the XAML markup, you can see what we've done so far. You can see that we've added a double animation using keyframes, and we have a keyframe at 2 seconds, and its value is 106. We must be animating, what is it? Well, there's a lot of stuff where I don't actually understand or need to care about, but clearly we're animating something, and at 2 seconds, its value is 106. You can examine that carefully if you need to. We've added an animation, but it really doesn't feel right. Let's run it again. That's not how gravity works. Balls don't just float down. There should be some sort of, well, change as the ball moves. To make that happen, we need to add an easing function. Now, what we'll do is in the Properties panel, find a section called Easing. Now, before I can do that, I need to select the keyframe, which is here, and now look for the Easing section in the Properties window. Now, we could use a key spline, an easing function, or there's an option to hold in. The one we care about now is key spline. Let's start there. You can see that you can define here your own key spline. I mentioned earlier that doing this without Expression Blend is awfully difficult, but using Expression Blend, it's pretty easy to modify this key spline function. What I want is something that looks kind of like this. That is, it starts slow and speeds up over time. Given that, let's try to play this again. Now you see it starts slow and then speeds up as it goes, which is pretty much how gravity works. I haven't made the effort to make it look really like gravity. I'd have to do some mathematical study to make that happen, but at least it does speed up as it goes along. Now if I want the ball to bounce, and I might want that to happen, I could repeat this by adding multiple keyframes and multiple spline functions, but that's really kind of a pain. What I want to do is use something built in to make this thing bounce, and you should by now know what you can use that will make this thing bounce. That would be an easing function. So instead of a spline, let's use an easing function, and we'll check for the bounce. And I think I want this thing to ease out. So we'll use the ease out mode here. And the bounces property should be 1. And the bounciness property I'll set to 2. At this point, if I looked at my markup, you'll see that I've created an easing function here, a bounce ease with easing mode of ease out. Bounce is 1, bounciness is 2, exactly as you saw in previous examples. Let's try running this again. Now you'll see it bounces and bounces. So it bounces once as we asked it to do. With the playhead still at 2 seconds, I'm going to move the rectangle a bit. So at 2 seconds, I want the rectangle to be, well, let me select first. I want the rectangle moved to here. So on that second bounce, the ball would fall through. Let's try that. And it seems to work. Of course, we'd have to do a little more work to make the ball fall straight. So let's move the playhead forward to 3 seconds. And at 3 seconds, I want the ball all the way off. There we go. Let's play it through now. Bounce and bounce it goes. Of course, I would need to actually add an easing function because it should get faster as it falls. I'll leave that as an exercise for you. But you can certainly see that we've managed to create very simply a convincing animation using Expression Blend and its tools for adding key spline or easing functions. We've also animated multiple objects, the ball and the bar, using the design tools built into Expression Blend. If I run this whole thing by pressing F5, you can see the application does, well, pretty much what I'd want. I have a little fine tuning to do, but certainly that was way easier than trying to create that animation from scratch.